Good morning to all. This is M. Visalakshi, Department of EEE in Tandai Periyar Government Institute of Technology, Vellore. Welcome to e-learning class. Today we are going to see power electronics under the topic of three-phase inverter using 120-degree mode operation. So, first introduction. So we all know the three-phase inverter with six-step inverter, and here it will be uh, for using adjustable frequency power to the industrial applications. And there is a six-step inverter, as I told already, six thyristors, and there is a step-by-step process as a change in firing angle from 1 to next thyristors with a proper sequence. Each are having with a regular interval of 60 degree, and here it will be consisting also three half bridge inverter arranged side by side. And from the circuit diagram given, and this is the three-phase inverter circuit diagram with the inverter using thick six thyristors. Okay, six thyristors we're using T1, T2 up to T6. So this is your T1, T2, T3, T4, T5 and T6. Okay, commutation and snubber circuits are neglected. Here three-phase inverter of three half bridge inverter with side by side, and load is connected in a star connected. Okay, so here this thyristor has numbered in a sequence triggered to obtain the voltage with VAB, with VBC and VCA, and output terminals are A, B and C. Each thyristor containing which conducts 180 degree, and each are 120 degree. Okay, and here we are going to see the conduction mode. So generally in three half bridge inverter with a star connected has two possible pattern of gating the thyristor. One is 120 degree and other one is 180 degree mode. And here we are going to see the 120 degree mode, and also it is very similar to 180 degree mode with all similarities, except the time of each switch is reduced to 120. Okay, so from the circuit, the equivalent circuit diagram, each thyristor will be conducting 120 degree with the six steps. So here there is a six steps, and we are going to see one by one. Each will be 60 degree of durations for completing one cycle of output VAC. Okay, so only two thyristor will remain on at any instant of time, and the per phase and line to line voltage waveform is attained. Okay, so as I told already, each with requiring six steps with a 60 duration for completing one output AC voltage. One output AC voltage. So starting sequence from the circuit diagram. So our steps sequence will be, first step will be T6 T1, and second will be T1 T2, and third T2 T3 thyristor, and the last one is T3 T4 thyristors. So this is the conduction table and also a phase voltage. Okay, so for the first row, T1 will be conducting 120 degree, and next is 60 degree. Okay, so here T1 and T4 will be conducting T1, T4. T4 will have omega with 180 degree, means 360 degree or 300. So T4 will turned off and T1 will be turned on. Okay, so this is what for conduction table 1 for the steps 1, and second row will be conducting. T3 will be on and omega will be 120 degree, which conducts for 120 degree, and then 60 degree will be elapses during T3 and T6 or T6. So omega will be 300, and here T6 will be on condition. So this is what we told. So 300, okay, and 120 and 160 degrees. Then T3 will be on. Okay, T3 will be on condition. And the third row will be each step 2 thyristors will conduct, one from upper and one from lower. 180 degree with 3 thyristor will conduct in each step. Okay, so here it will be, this is your conducting thyristors, and this is your step 1, 2 up to 6. Okay, so again it is repeated 60 degree, 120, 180, 240, 300, 360. So this is your conduction table, and here it is a equivalent circuit for each steps. Each step conducting with an equivalent representation circuit. So we told for step 1, thyristor 6 and 1 will be conducting. Okay, so 1 and 6 will be conducting, and here A will be positive bus of DC source, A will be, and B will be negative source, and C will not connected. Okay, so from your circuit diagram, C is not connected. So the formula appeared for VA naught will be equal to supply voltage by 2, and VB naught will be minus VS by 2, and VC naught is 0 since it is not conducted. Similarly, in step 2, 0 to 60 degree. Okay, for step 1, and for step 2, 60 to 120 degree. 1 and 2 will be closed or conducts. Okay, for step 2, and load voltage will be V naught equal to Vs by 2, Vc naught equal to minus Vs by 2, and here B will not be conducted. This is your step 2. Okay, and similarly for step 3, 120 to 180 degree, 2 and 3 will be closed. Thyristor 2 and 3 will be closed, and respective circuit diagram is here appeared. Here VA will not conduct. So VB naught will be positive DC source Vs by 2, and VC naught will be minus Vs by 2. VA naught will not conducted. Okay, and for step 4 will be 180 to 240 will be conducting. 180 to 240. Thyristor 3 and 4 is closed. So here it is closed. Okay, so thyristor 3 and 4. And here it will be A and B. Okay, and similarly C naught will be closed and it is not conducted. This is for step 4 thyristor. Similarly for the output voltage waveform will be appearing with the respective uh, waveforms conducting thyristor with respective thyristors VA naught, VB naught and VC naught according to the thyristor steps conducting. So we told 1 and 6 will be conducting, and 1 and 2. So 1 within 120 degree. So it is 120 degree, and the respective voltage is plus Vs by 2, and for B naught, okay, so B naught will be negative. So minus Vs, okay, minus Vs by 2 and plus Vs by 2 it is conducting. Means 120 to 240. So here it is represent, and similarly Vc naught. So Vc naught will be 1, 2 and 3, 4 will be conducting. So here it is, okay. So conducting thyristors are 1, 2, 2, 3, and similarly 4, 5, 5, 6. Okay, so it is repeated. So for output voltage V0 will be VA0, VB0 and VC0. Only two output terminals will be conducting to the DC source at any time. Okay, so this is your output line voltage waveforms. So based on your conducting thyristors, and using Fourier analysis of output voltage. So this is the formula to calculate VA naught. VA naught will be summation of the thyristors 1, 3, 5 to infinite 2 times of Vs by n phi cos n pi by 6 into sin n omega t plus pi by 6. Okay, so pi by 6, 30. And B naught will be same, only difference is minus pi by 2. Okay, and similarly C naught will be same, plus 5 pi by 6. So this is your to calculate the output voltage equation. And next is to find the line voltage. Okay, so it is similar line voltage VAB. Okay, so VAB will be equal to summation of n equal to 6k plus 1 to infinite 3 Vs by n pi sin n of omega t plus pi by 3. So where k will be varying from 0, 1, 2, 3, okay, up to the value, and it is similar to find VBC and VCA. Okay, so same formula will be appearing for calculating the line voltage waveform. And to calculate the RMS value of the phase voltage for phase 1, it will be 2 Vs supply voltage by square root of 2 pi cos pi by 6. So when we substitute calculate all the values for fundamental phase voltage 0.3898 Vs, this is to calculate the phase voltage RMS. And here RMS value of phase voltage, this is RMS value of fundamental, and phase voltage will be 1 by pi 0 to 2 pi by 3 Vs by 2 into 1 by 2 d omega t. Okay, so here after calculating the values and applying the integral, okay, after calculating the integral value, square root of 2 by 3 Vs by 2. Okay, after calculating this, Vs by square root of 6. So phase RMS value of phase voltage is 0.482 Vs. Okay, and again to calculate the line voltage, so here VL1, okay, line voltage 3 Vs by square root of 2 pi. So value will be 0.6752 Vs. Okay, so to find line to phase, VL will be root 3 times of V phase generally. Okay, so here RMS value of line voltage is square root of phase voltage. So we know from the previous slide phase voltage is Vs. Okay, so Vs by root 2. Okay, so after calculating the root 2 1.414, okay, 4141 by, so the answer for VL to supply voltage is 0.701 Vs. So this is the final tabulation for 6 steps of different thyristors. See, for calculating the first step, thyristor 6 and 1 will be conducting my RYB phase. Okay, so RYB will be Vs by 2 minus Vs by 2 and 0. So in previous slide we saw this as VA naught, VB naught and VC naught. So this is the similarity, there is no other changes or there is no difference. So VA naught, VB naught and VC naught. And similarly for step 2, thyristors conducting are 1 and 2, VA naught and VC naught will be conducting, VA naught, B naught will be closed. And this is followed for all the 3, 4, 5, 6 thyristors. Which thyristors are conducting and which thyristor value is closed means the voltage value is closed. Okay, so star delta, right? So star delta VABC, ABC A will not be conducting, so 0, and C will not conducting and B will not be conducting for each thyristors. And to find the voltage, so this is the formula. Okay, but the angle will be varying, minus 30, plus 30, plus 90, 150, 210 degree, minus 30 degree. So voltage value will be varying. Okay, so these are the conditions how to conduct 120-degree mode using thyristors, 6 thyristors with each different steps. Thank you.